Sam Altman is the CEO of OpenAI, the company behind the now famous ChatGPT, a breakthrough language AI. He used $180 million of his personal wealth to fund Retro Biosciences, a company focused on human rejuvenation which has a mission to increase healthy human lifespan by 10 years. Altman works closely with Joe Betts-LaCroix, Retro's CEO and co-founder. Betts-LaCroix notes the company is all about creating something that billions of people can benefit from and that is generally affordable. What are the rejuvenation projects Retro is working on now? Let's hear what their CEO has to say.
Our mission, which will not be lost on you, is to add 10 years to healthy human lifespan. We're not into creating things for billionaires. We don't want to discriminate against billionaires. I'm just saying we don't want therapies that are super expensive and awkward and difficult to implement and only a few people can afford to use them. So that's another criterion. They have to become like distributable therapeutics. So what are the commonalities between these things in the title of this talk? Between reprogramming and autophagy, they're both cell autonomous fundamentally. Between autophagy and plasma, which is what I'm referring to by parabiosis. They're deeply engaged in the proteome, at least the way we're working on it. And the way we're working on it, reprogramming and plasma, we're working heavily in blood for our partial reprogramming efforts. The trite answer to what's the commonality between all three of these phenomena is Retro. We are, like I say, a startup going after aging writ large in Redwood City. We have an initial funding of $180 million, which will last us minimally for 10 years of our work. We got going immediately by converting 40 shipping containers in a giant warehouse, 23,000 square foot facility into lab spaces, one of which is depicted in the background. We are challenging ourselves to have a clinical trial in our partial reprogramming in humans by 2026, and a couple of different trials in our plasma program, one next year for the discovery process, and in 2025 for efficacy, and in our autophagy program, a clinical trial next year. We will have approved therapeutics in patients before the end of the decade. Thank you. So to that, I have the intimidating honor of following Jean-Marc like a global reprogramming expert. Our advisor, Alejandro Ocampo, figured out that, well, let's say you don't do this Yamanaka reprogramming continuously and create a pile of protoplasm, but instead you just do a little burst, just a couple days. And if you only go that far, then amazing things happen. He showed in mammals, our criterion, that there are rejuvenated phenotypes, a bunch of different rejuvenated phenotypes, and they don't end up getting cancer or having other things that destroy their bodies. So that's like, what? We can just reprogram cells and entire bodies and not kill animals and not probably not kill people. That's incredible. This is a whole new branch of biology. Since then, a bunch of labs all over the world have replicated this in various different tissues of various different phenomena, phenotypes, age-related characteristics that are reversed to a more youthful phenotype in muscle, heart, lung, skin, liver, optic nerves and eyes, even brains. Like mice seem to have better memory if you partially reprogram them. And for the work that we're doing in partial reprogramming, T cells. Having more youthful T cells turns out to be very useful, because T cells, the immune system itself is such a fundamental part of the body. Like if you go any direction on average in a tissue, within about 3 cells you'll hit an immune cell. We have another program in autophagy. Autophagy is one of these things, like, I don't know, like the nutraceutical vendors will try to convince you that all oxidation is bad in the body and you should take antioxidants, and the antioxidants will solve all of your problems. But it turns out that it's actually a lot more complicated than that, and oxidation in its various forms is critical for being alive, even for T cells functioning. Autophagy, similarly, is incredibly complex because it's basically every single broken thing or unused protein, et cetera, has to get broken down and reused, made into its component parts and reused inside the cell. So there's a lot of different mechanisms for that. But in just one of those, we have found a target that is related to some aging phenotypes, some important long-term aging issues. And there happens to be a more acute disease that is also related to a failure of this kind of autophagy. And plasma parabiosis side, the history of that, which he already described, is that you do this kind of grisly thing where you like sew together an old animal and a young animal, and he was talking about the younger animals getting older, but also the old animals get younger, and that's pretty remarkable. It's a little less clear how you intervene. So how do we make that into satisfying one of those criteria for things that we want to work on at Retro? But then later, we were also inspired by some results from Convoy Lab at Berkeley, where they were able to only take plasma out and showed some rejuvenated phenotypes, as Lou mentioned as well. And then I just want to put a plug in here for Vadim Gladyshev. You may be in the house, incredible scientist, one of our advisors. In his group, they showed that you can detach the parabionts, as you call them, after a few months, and then the older ones continue to have a rejuvenated phenotype afterward, which is pretty exciting. So we don't really want to have, again, these old billionaires having to pay the young plasma donors to come give them donations, because that violates one of our tenets. So we're not doing that. We're making medicines. And how do we make medicines out of this? Well, so I think that what Lou was saying is that pretty much all of the effect of the heterochronic parabiosis seems to be the kind of the red side, like the taking out of the bad things. We replicated the Convoy's experiments. We repeated them, I'd say, with a larger N, like number of animals in the groups and so on, under extremely carefully controlled and blinded conditions, and not all of it replicated. So we don't feel as strongly that everything would be on the red side of like taking, take the bad stuff out of the old animal. We think that there is a bunch of utility in what is the good things that come from the young animal as well.